Okay, so okay, first I'll show you the architecture, how architecture works basically in NetApp in hardware level. Okay, so you can see here, this is the first, there is a disk, right? On the top of disk, after that there is a aggregate. I'm showing you the architecture basically. Okay, now I can show you the another things, that is a volume. I will write here also. And after volume there is a Q3 here.
So we have disk, aggregate.
Yes.
Volume.
So yeah, first there is a disk. When there is a NetApp box, this is a newly or whatever it is in the old. So first there is a disk, right? With the help of the disk, on the top of the disk, aggregate is being created. With the help of the disk, aggregate is created. Okay.
Okay.
Okay. And then inside the aggregate, volume is created. Volume is the lowest level of the architecture where client data is being saved.
Oh, okay. I got it. Okay.
Okay. So once the volume is created, the volume will be created inside the aggregate. Okay. So create the LUN. LUN is basically term is being used in the SAN environment. Okay. If we are not using a SAN, we are using this NAS. Okay. Like NFS you are using, right?
Yeah.
So we don't need to go to the LUN level, right? So if we are using the NFS, NAS environment, shifts or NFS, then we need the volume only till here.
Okay.
Okay, so volume is the lowest level where data is getting saved, client data.
Okay, got it.
Okay, so basically this is aggregate, and this is a Q3. Q3 basically optional. If you want to create a Q3, that's okay. Q3 is basically used for the quota creation purpose, right? If you want to restrict the utilization of the disk aggregate, in
Okay.
that situation, you can create a Q3. In later lectures, we can discuss on this point.
Okay.
Okay, so Q3 basically a optional thing. If you want to create a, you can create, otherwise you cannot create. You when you create a volume, on the top of volume you can create the LUN. If you are not using the SAN environment, you can directly assign the volume to the client, right? If you're using the NFS, then you have to create the junction path over here, namespace junction path. Okay, and you can assign the NFS to the Unix server directly, and Unix server will mount and it will say, start saving the data in the volume directly.
Okay, got it.
Okay, so this is basically the structure, the hardware structure. Okay, so now we'll discuss about the disk. Okay.
Okay, good.
Okay, so first this is on tops. So basically we'll discuss about the disk first.
Okay, good.
Okay, so when disks are installed in the NetApp, whether it is in disk shelf or it is in controller, right? It is in raw format basically. That is known as unassigned.
Okay.
Unassigned means you cannot use this. Okay, and in the NetApp controller by default the option is off. This you can auto assign as well. You can enable the auto assign so that if any disk is inserted in the disk shelf, right, in bay, it will be automatically assigned to any controller. This will be assigned to, this should be assigned to any controller, whether in the cluster, whether it should be assigned to node 1 or it should be assigned to node 2, but it should be assigned if node want to use it. If that will not be assigned, this will not be used. This is unused basically.
Okay.
Okay, so you can assign the disk manually, right? Or you can make it option enable so that it will ONTAP will automatically assign the disk as per the requirement.
Okay, got
Okay.
it.
Okay, so this is unassigned disk. So when we assign the disk, it will go inside the spare. Let me tell you the types of the disk here, so that it will be easy to understand you.
Okay, got it. Thank you.
When we are discussing about the aggregate, right, and data, so this, I'm not talking about the hardware level disk type. Okay, SAS, SATA, and SSD and VME. That is not the one. I'm talking about the based on the aggregate types.
Okay.
Base uh, aggregate oriented and data oriented this type is. Okay, so first I can tell you this is the parity disk. Yeah, yeah, right. Parity disk. Yeah, yeah, right.
Parity disk. Okay, got it.
Okay. Second one is pair disk.
Okay.
Okay. Third one is the data disk. Okay. So what parity disk is? Basically, this is the feature of the RAID group. RAID group means this parity information kept when we create any RAID group. So some dedicated disk is kept for the parity information. Parity information means all the combined data will be saved in the format of the parity. And this will be for the data redundancy purpose. In case any disk is failed, the data from the parity will be reconstructed to the new the failed disk only when we replace that.
I see.
You're getting parity information means all the data disk information will be kept in the parity disk.
Okay.
And whenever it is required, the data will come from the parity disk, and it will be reconstructed, and it will make as a original data. I will show you in the diagram also later on. So first you understand the parity information means this is the feature of the RAID group. Whenever any disk is failed, right, this will be replaced, and that data will be reconstructed from the parity information. So data will be saved if parity disk is there. If parity disk is not there, disk got failed, means that all the data inside that particular disk will be lost. Okay.
Okay.
But if there is a parity disk, data is saved in the parity disk. Okay. Once you replace the faulty disk, that original data which disk is failed, that original data will come from the parity disk. Okay. You're getting?
Yeah, I'm getting it.
Okay. Okay. Thank you. Next one is spare disk. Spare disk is basically the disk which is all time available to replace the faulty disk. Right.
Yeah.
So suppose we have a 2 node here, NetApp node. So it is recommended to have at least 2 spare disks per node. Okay. If you don't have a spare disk and this disk got failed, in that situation you will not be able to replace the disk. Okay. So okay, so per node it should be, let me create a stack. Suppose this is the disk shell basically below. This is a complete disk shell. So 2 disks should be always available for to replace the disk, faulty disk. So 2 spare disks per node should be available.
Oh,
okay.
That's a backup.
Okay, so this is there is no any data in the disk basically. This is available only. This is available to replace.
Yeah.
Okay. Okay, so this is the spare disk basically. Okay. Next we are discussing about the data disk. Data disk means the disk which is used for the data purpose. Okay, to save the client data. In that data only we create the aggregate, we create the volume, and all the data from the client is saved inside that. This is yellow one. You can say. Okay. So this is the disk type that we have discussed. Okay, architecture we have already discussed. Okay, so let me show you about the aggregate now.
Okay.
Here it is clear, right, Shan?
Yeah, yeah, very clear.
Okay. Okay. Thank you. Save this one. Okay, so let's come to the aggregate part now. This is the main core part model, right? So aggregate is basically the collection of the disk. Okay.
Okay.
So aggregate is basically collection of the disks and which is created on the RAID group, basically for the redundancy purpose. So in simple way, we can understand the collection of disk.
Okay. Aggregate is okay. So you have all the disks in the, so one node has, let's say, 14 disks or 24.
Yes.
So
suppose there are disks. This is disk shelf, right?
mhm,
This is disk shelf. There are multiple disks are there inside one.
mhm.
Okay. So when we do create a aggregate, so you can consider a combination of the disk.
Mhm.
Okay. It will make one aggregate. The
Mhm.
group of disks will make aggregate. In simple way, you can understand.
Mhm.
It is clear here.
Yeah, it is clear.
Okay, so simple way the collections of the disk is known as an aggregate. Okay,
And you can
so
make it any way you want. Even let's say you want to create aggregate, not of all the disk. Maybe you want to create two aggregate.
we are coming to the point.
Oh, okay, got it.
We are come to the point. Yeah, we are yet to come. Okay, so we can create that. If you answer your question, we can create that. But we have to discuss the some negative and positive points.
Okay.
Whether should we create or not?
Okay.
Right? If you are going to create, what could be what is the impact? Are we compromising with the no redundancy?
Mhm.
Right? So all these point we'll discuss. Okay,
Okay.
so aggregate this one we can discuss about the types of the aggregate, how many aggregate types are there. Okay, so I'll show you. So first one is the root aggregate.
Mhm. Okay.
This is known as a AGA 0. Okay, second one is the normal data aggregate.
Mhm.
Third one we can say a hybrid aggregate. This is also known as a flash pool.
Okay. Okay.
Okay, so when we are configuring, when we are installing the operating system on tap on the NetApp box, right? When we are creating a cluster setup, so by default root aggregate is getting created.
Mhm. Okay.
Okay, so aggregate 0 will be created, right, per node, and inside the aggregate 0, wall 0 will also be created. That is also by default.
Mhm. Mhm.
Okay, so the aggregate 0 and wall 0, that is known as a root aggregate, root volume, and both are created as per node. Every node, when how many nodes you will create, you will add. So these root aggregate will be created that, right?
Mhm.
So whenever on tap, whenever cluster is getting rebooted, so first it will upload the operating system from the compact flash,
Mhm.
and second step is to upload the system information from the volume wall 0.
Mhm.
That is root wall. Okay, and that root wall is residing inside the aggregate 0, root aggregate.
Mhm.
It is clear.
Okay.
Okay, so this is the root aggregate basically. So and the second one is normal aggregate, normal data aggregate that we normally we create for the data user for the SAN and NAS data, right? Okay, so mainly we'll discuss on the second point. So I'm telling you the types of the aggregate here. So hybrid aggregate is basically used for the performance as well as the capacity. So
Okay.
hybrid means when we are going to create the aggregate with by using the hybrid disk, you can say. Hybrid disk means SSD SATA drive you are using, disk you are also spinning disk you are going to use, as well as the SSD disk you are also going to use.
Mhm.
Right. Suppose you are, let me show you little diagram so that will be easy, more easy. Okay. So this is flash pool. Flash pool is basically, flash pool is also known as a hybrid aggregate. Hybrid aggregate means combination of the SSDs, flash as well as the HDD. Okay, so this aggregate has been created with the help of the disks. Multiple disks are there. So since this is a hybrid aggregate, so you have added some SSD disk, right? So this is the SSD disk, and some are the spinning disk, means HDD. Okay. So what happens? How it function basically? Let me show you. You can consider this is the SSD disk, right? And this is the HDD. Okay, so you can see the blue one is the HDD, that is spinning disk, and the this you can see the yellow one is the SSD disk basically. So in hybrid aggregate, what happens is SSD disk is not being used for the capacity basically. It will the SSD disk will fronting as a cache.
Okay.
Okay. SSD disk will be fronting as a cache, and the HDD will be HDD will work as a capacity. So whenever you are going to use any data, so that capacity, that data will be saved in the capacity in HDD, right? And this SSD will work as a cache. Okay.
Okay.
So in this aggregate, the read performance will be high.
Okay.
Okay. So this is the purpose of the hybrid aggregate basically, right? So now we'll discuss about the aggregate, which normally is being used in the industry, right? That is a normal data aggregate.
Mhm.
Okay. So when we are going to create the aggregate, basically it requires the RAID. So if you're talking about the NetApp support three RAID groups.
Okay.
Okay. So first one is RAID 4. Okay. And the second one is RAID DP, and third one is the RAID tech. So I'll tell you the differences between the how can we create types.
Mhm.
Okay. So RAID 4, when we are discussing about the RAID 4, once we are going to create or aggregate, it will ask which RAID group you want to create, right? In which, so if you're defining the RAID 4, so RAID 4 is protect from single disk failure. Suppose the RAID you have already you have created the aggregate, right? And you have created the RAID 4, and one disk got failed. In that situation, the parity information will be saved in single disk. Okay, since this is single parity RAID,
Mhm.
and RAID DP is dual parity. You can see the naming convention DP. DP is dual parity. Dual parity means this RAID group have a dual parity.
Mhm.
Two disk, it protects from the two disk failure.
Mhm.
How it was means the parity information is kept inside the two disk. Okay.
Mhm.
Okay. And then third RAID group is RAID tech. RAID tech is basically the third RAID group is it protects from the three disk failure, right? And to create the RAID tech, minimum 6 TB drive should be there. And if you have a 10 terabyte disk in disk shelf, you have to create the RAID tech. The RAID DP will not be supported, right?
Mhm.
So it is clear till here.
Mhm. Mhm. Yeah.
RAID 4 is basically a single parity. Okay, this one is single and the other one is 2 and 3. Okay, so create a RAID 4, we need minimum 3 disks. So if we have it to create a data disk, we are talking about that. If we are going to create a data aggregate, we need a minimum 3 disks. And in case of the creating data aggregate, we need a 5 disk minimum for the RAID DP. Okay, and similarly, if we are going to create a RAID tech RAID group, minimum we should have a RAID 7. Sorry, number of the disks should be a minimum 7 number of disks. Okay, okay, so you are asking about suppose we have a to, let me show you that. This is disk shelf basically, and these disk shelf have a 24 hard drives. Okay, so total is 48 disk drive, right? So your question was, can we create a big size of the aggregate of large number of disks, right? Suppose we have 48 disks. Can we create aggregate? It is advisable or not? So 24, this is disk cell, 24 disks here and 24 disks here, right? Total 48 disks, right? So total 48 disks are there. So now we have to create one aggregate. So suppose we are thinking whether we can create aggregate or not. This is your question, right?
Yeah.
Can we create a aggregate with large number of disks, right?
Yeah.
So this is, we can consider it 48 disks, right?
Yeah. 12 disk aggregate or something like that.
Yeah. 12 disks, right?
Yeah.
So 12 be advisable. It is good.
Okay.
But if you're yeah, that is good. So, but if you're talking about the 48 disks, you're going to create an aggregate with the 48 disks. This is not advisable at all.
Okay, makes sense.
Okay. So why? Because suppose 48 disks, if you're going to create,
Yeah.
so you have a 48 disks, 46 disks will be there, right? 46 disks will be there, data disk, and two disks will be the parity disks will be there. If you're going to create a RAID DP,
yeah,
suppose it's below 6 TB, right? So you have to create a RAID DP. Okay, so 46 disks will be for the data, right? 46 disks will be for data.
Yeah.
And 2 disks will be for parity information, right? So in that situation is very more chances to get the disk failure more than 2, right? Because there are multiple number of disks, right?
Okay.
So this is not advisable. Suppose two disks failed, right? So it is okay. If 2 disks is failed, that is okay. It is survive from 2 disk failure, since this is a parity information here. This is parity disk. Okay, so if suppose 2 disks got failed, 2 disks failed at the same time, so the data can be reconstructed from this one, right?
Yeah.
But suppose 3 disks, there are very more chances, but often it does not happen. But no one wants to take the risk, right?
Yes.
So this is this is not advisable basically.
So it's like putting all your eggs in one basket is not a good idea.
This is not a good idea. Basically, this is aggregate. So what is advisable? Basically, aggregate is same, right? We are creating the aggregate, right? We are this is the aggregate. But what advisable is there? You can create a 3 RAID group in single aggregate with 16 16 16 disks.
Oh, that's better. So, okay.
Yes. So this will be very balanced between the capacity as well as the redundancy. You are very much redundant on the data purpose, right? How it works, I'll show you a little bit diagram, so it will be more easy also. So suppose this is a RAID group. Aggregate will be the only one, right? But RAID group will be 3 inside the one group. Okay, so this is the priority information.
Mm-hmm.
You will get little less capacity because priority information you have a 6.
Mm-hmm.
When you're going to create a 3 RAID groups, so you have to keep the priority information as well, right?
Mm-hmm.
So if you are creating aggregate with 48 drives, you will get little bit more capacity. Why?
Mm-hmm.
Because only 2 priority disks is being used, right? But
Mm-hmm.
when you're going to create a 3 RAID groups in DP, so you 6 disks will be required, but 4 more disks is required for that. But here it is very more redundancy. Data is very safe.
Okay. Okay.
Okay, so this is advisable to create a 3 RAID groups rather than creating one single RAID groups in aggregate.
Okay. Okay. So you take aggregate is based on disk shelves. So one disk shelf, let's say the 24 disk, you would make one aggregate, and then the second disk shelf, you make that into another aggregate. But inside the aggregate, you can create a RAID group.
Yeah, forget about the disk shelf here. I just show you the diagram. So aggregate node will see only the disk.
Okay.
Okay. So you have to consider here only disk, how many disks you have. Once you run the command disk show, okay, yeah, store a disk show. So it will display the all disk number of the disks.
Okay.
So you need the disk number only, not required the disk shelf here. Okay, so you have to consider. I just only show you there are 2 disk shelves. So in one disk shelf 24 disks, 24 disks. So you have to consider only 48 disks here.
Okay, so you consider
Okay.
one whole
48 days. So you have to decide 48 disk you have and how you are going to create the dish aggregate with the help of 48 days. Okay. So whether you are going to create in the single RAID group or multiple. So it is advisable to create a multiple RAID groups in single aggregate. Okay.
Oh, so you take all 48 disks, make a one full aggregate, but then you break it down into multiple disk groups.
Yes.
Parity group. What do you call it?
Exactly.
Okay, got it. Now I get it.
Yeah. Okay. So this is all about the aggregate. If you have any other question, you can ask me till here.
No, so basically, you have 2 disk shelves and it has 24 disks, 48, that becomes 48 disks. You create one aggregate and that it becomes one aggregate one. And that's where you first start your dividing. So you basically grouped everything into one, and then you are kind of creating RAID groups based on what you need.
Yes.
Something like that. Okay.
Yes, you're right. Okay, so this is all about the aggregate. So in this one we have to consider that this aggregate, right? So what else is there on the aggregate? So aggregate. I have some slides, so I'll show you that also. Let's go through that. Okay, so we already discussed about the disk ownership. I'll show you some commands as well, how to run the command and what is the use of these
Yes,
commands
please.
also.
So
Okay.
I want to compare that. So
Yes.
production, so I can see not destructive, but just kind of view command, so I can see how.
I'll show you. I'll discuss on that part also. I'll explain about the commands. I'll share the commands as well. Okay. So I would like to tell you a little bit more about this.
Yeah.
Okay. So disk ownership already discussed, right? So disks and aggregates are owned by one node. So we have to make sure that the aggregate is owned by one node, right? So this is the primary accessible. Whenever any client is requesting for the data, so it will come via the direct path. Basically, if suppose node 1 has a ownership of aggregate 1, so the aggregate 1 is the direct path for the node 1. Okay, if that data is being accessed by the node 2, that is an indirect path basically, and that happens in the case of controller 1 is failed. Okay, So node 2 peer can be take ownership of this. Okay. So all the disks and aggregates are owned by separate nodes, right? Aggregate 1 is owned by node 1, aggregate 2 is owned by node 2. But when aggregate 1 is taken care by node 2, that in the event of the any failure, node failure or any crash happens, right? The SAS connection from the HA active standby. Okay, so the SAS connection between the disk shelf we discussed in disk shelf module. So one will be active and that another will be passive. The primary one will be active, right? And the secondary will be the passive basically. Suppose node 1 has a connection of the disk shelf below that controller, so that is the active one basically. When the node 1 will connect to partner disk shelf, that connection will be the passive basically, that will not active.
Okay.
So that will active when the partner node will be failed.
Okay. Okay.
Okay, so node can be reached other node aggregate over the cluster interconnect switch. Okay, so when the node got failed and keep alive will be not sending to each other, so the partner node will be taken over via the cluster switch.
Mhm.
Okay, so this is how the diagram is. So this is controller 1, right?
Mhm.
You can see the controller 1 and aggregate 1.
Mhm.
So below controller 1 aggregate 1 means this is the own, this aggregate is owned by controller 1. You
Mhm.
can see here.
Mhm.
So this is when any request will come for this aggregate. So
Mhm.
this request will come from the controller 1 only.
Mhm. Mhm.
Okay, so you can see the red dot is this is a passive path basically.
Mhm.
This controller, this shell be also accessible from the controller 2, but this is the passive path. Okay,
Mhm.
this is not active as of now.
Mhm.
Okay, so this is how the data is being accessed for the client. This blue data is being accessed, blue path is that. Okay, so okay, so if suppose there is a NFS or NAS environment is there, two IPs will be there, right? If client is accessing the partner node controller 2, but for the aggregate 1, suppose volume is here only inside the aggregate 1, but client is accessing the data from controller 2. So
Mhm.
in that situation, the data, how data will be transferred? The request will come from this to
Mhm.
the controller 2. Controller 2 will go to the cluster switch. This is the connection. It will request from the controller 1 only, but the data will transfer via this connection,
Mhm.
via cluster interlevel. It will come from the aggregate 1, and then data will be transferred like this. This is
Mhm.
the indirect path basically.
Mhm.
You can see here indirect path.
Mhm.
Okay, so controller takeover, how it happens basically, this is the high availability. Okay, so in the, if keep alive will not be sent from controller 1 to controller 2, the control 2 will understand that there is something happen, and
Mhm.
all the responsibility, all the aggregate, all the logical interface will be taken over by partner node controller 1. And that situation, all the request for the aggregate 1 will come from the control 2 only. Okay,
Okay.
and in that situation, this path will be active now. You can see the now that the data is not being transferred via this switch,
Uh-huh.
right?
Uh-huh.
This will happen only when this the controller one will fail, and that situation this passive path will be active now.
Okay.
Okay, so this when the data will be requested from the user host server
Uh-huh.
to the controller 2 will directly access the node aggregate 1.
Okay.
Okay,
Mhm.
in same this is the 2 node cluster, right? So if in case of the 4 node cluster also is happen same, all the nodes are 2 nodes are in HA, right? So 2 nodes are in HA, so there is a connectivity, this shelf connectivity also there, you can see here. But if suppose there are 4 node cluster and the aggregate is in controller 1,
Uh-huh.
controller 1 got failed. Okay,
Uh-huh.
so this aggregate is accessible from all the nodes you can see here
Mhm.
in the cluster. Okay,
Mhm.
okay, suppose user host server is sending a request to controller 4, because this is the same cluster, right?
Mhm. Mhm.
If with the sending the cluster 4, the request is terminating on the 4, so the 4 cluster 4 will travel via cluster switch, right? This network, and it will go to the controller 2, and the control 2 will directly access the data from aggregate since this controller is not working.
Mm-hmm.
And in this case, the direct path will be active. The passive path will be active here.
Mm-hmm. Mm-hmm. Okay, got it.
Okay. When the system is power on, it load the ONTAP system image from the compact flash. Then the system information from the disk, right? The lowest level data is accessible at the volume level, right? So we need an aggregate and volume to hold this information. The system node root aggregate and okay, so we have already discussed, right? So whenever any node is powering on, right? So first it will load the operating system ONTAP from the compact flash, right? Then it will load the system information from this disk. This means the root aggregate and root volume, right? And the volume is the lowest level where data is getting saved. Okay.
Mm-hmm.
The root aggregate system information is replicated through all the nodes. So this is root aggregate. Every node is holding the root aggregate and root volume. So whenever we are changing any information, right, system information is being kept inside the root aggregate and volume, right? So if you are creating any information or changing any information, any modifying any information in root aggregate volume 0 in node 1, right, controller 1. So this information will be replicated to all the nodes in the cluster.
Mm-hmm.
Okay. So this is known as basically RDB. So this replicate via cluster network.
Mm-hmm.
Okay. Every node in the cluster has its root aggregate root volume. If the system is factory resetted, then all is wipe out and then aggregate are created. Okay. So once you boot the system, then there is an option, right? So system maintenance window, you will go as so you can wipe if in case of the factory default set wipe out. So and then you install the operating system again. Then you have to this aggregate 0 will be again created automatically. Disassigned to can be disabled. I told you that, right? So when you are inserting the disk, right? Suppose one disk failed in the disk shelf. You got the information. You vendor dispatch the disk. It got replaced. But if auto assign is disabled by default, it is disabled, right? So you have to manually enable it, right, by the command. I'll show you the command as well. Okay. If you do this, you will have to manually assign the disk, and you have to add this before you can add it. Okay. Okay. So if auto assign is disabled, then manually you have to assign it, and then you can use it. Now, once you assign, this will go to spare disk first, and from the spare disk, you can assign. You want to add in any aggregate, right? So you can add that from. Otherwise, it will be kept inside that spare disk only.
Okay. Yeah, it's also it should be auto assigned all the time. But it preferred when that way it can.
Yes, it is preferred. You have to assign it.
Yeah.
Right. Yeah, this is very preferred to assign it. Let me walk through about this and the slide as well.
So eventually, so there's quite a few questions which arises. One is when these concepts come, how do I check like the commands I can use to check either from GUI or preferably from command line that if a setting is assigned like current state, like means how do I
Okay. So if you want to see the command, if you want to see whether any disk is unassigned state or not, right? So you can run the command storage disk show hyphen field unassigned hyphen field. Field is very useful command, right? If you want to see any information, everywhere you can put the field. Storage disk show hyphen field unassigned. It will show all the unassigned disks. If there is no any unassigned disk, you cannot find any result. It will show their empty disk, empty result.
Okay. What
Okay, so I
about if to check because check if it's auto assigned or it's manually assigned. So what we can do is I don't want to disturb you during training because then
no problem. Yeah, it's okay, no problem at all. Let's discuss that command you're asking, right? I'll show you.
That's what,
Okay.
Cool. You're prepared.
This is what you are talking about, right?
Yes.
Okay, so first of all, once you run this command, storage disk show. Okay.
Yeah.
So this command will display you all the disks.
Okay.
installed, physically installed in the node 1, node 2, means how many nodes are there, right? It will display all the disk detail, right?
Okay.
Which disks are owning node 1, which are owning node 2. If more cluster nodes are there in the cluster, it will completely show you about every disk information. Okay.
Okay.
Secondly, if you want to see if any disk is in unassigned state or not, right? You have to run this command:
Okay.
storage disk option show hyphen field. It is auto assign, means it will show you auto assign is not. Sorry, let me remove it. Assign.
Uh-huh.
Okay.
Uh-huh.
Okay. So it will show you if any disk is, sorry, unassigned.
Uh-huh. Okay.
Okay. So this field will show you unassigned disk.
Yep.
Okay. Let me little bit show you here. Show option disk show. This command show. I'm forgetting that command basically. Hyphen field. Container type dish. Okay, so this command will work.
Okay.
Container type.
Uh-huh. Okay.
If any disk is in unassigned state, it will show here. Okay, and
Okay.
then you can assign.
Okay.
Okay, so the next one is the zero spare. Zero spare means when you assign the disk, right? You
Uh-huh.
assign the disk, this is in spare disk, but it's not is usable. It will show you not zeroed. Not zero means you can see the disk is required to format, right? The zero means doing zeroing means you're formatting the disk. Okay, so before assigning to the aggregate, you have to zero the disk. Means
Uh-huh.
you have to format the disk.
Formatted this. Okay.
Okay, so to run that command, store a disk zero spare. Once you run this command, all the unzeroed disk will be zeroed. Okay,
Okay.
and that will be available to assign in aggregate.
Uh-huh.
Okay, so next command is store a disk option modify auto assign on and off. Okay, so if you by default the auto assign is off, right? If you want to make it on, if you want that any disk is no inserted, it will be automatically assigned. So you have to make it on. Your auto assign, you should make it on.
Uh-huh. Yeah.
Okay.
And you can aggregate show.
Yeah.
Aggregate.
So store a disk show aggregate. If you want to see the complete information about the particular aggregate, right? You have multiple aggregate 1, 2, 3, 5, n numbers. So, but if you want to see the particular information about aggregate, you have to basically mention the let me show you about this command. Store a disk show is about this particular aggregate, how many disks are involved, how many disks has been added in this aggregate particularly basically. So once you run this command, store a disk show, it will display the complete disk information about the particular aggregate. Suppose you have created aggregate 2, right? You have added the 7 disks. So it will display the 7 disk information only. Okay. So next one is storage aggregate show spare disk. Okay. So if you want to see this spare information about the disk and for any node, right? So it will show you the spare disk information. Aggregate show -r and then aggregate show. It will be granular information. It will show you. Okay. So once you run any command for the particular aggregate, I can show here. Suppose that this is the aggregate, right? 3 aggregates have been created.
So we created a new, you created an aggregate called N1, aggregate 1, N1, and you put.
Yeah, this is one aggregate data aggregate I have created here. And this is the by default aggregate you can see here, right? Aggregate 0.
Is that the root aggregate?
This is the root aggregate basically. Okay. So I have created aggregate 1 N1, means on the node 1, right? You can see the information about this is aggregate name, it will appear here. Complete size, it will appear here. How many sizes are there? Complete size. Available space, it will show you here how many available space are there. Okay. Used capacity, used information, percentage used, it will show here. So normally 95% will be show everywhere in your organization. Also it will show 95% for the aggregate 0, root aggregate. Okay. Okay, so how many volumes has been created within this aggregate? This information will appear here. Right. So here it is 0. This is data aggregate. I only just created the aggregate. I did not create any volume. So volume information you appear here, right? So this aggregate is created on which node? So this is on the node 1.
So okay, so you cannot choose both the nodes to make this aggregate. You only created aggregate from the node 1.
Yes.
Okay, got it. Okay.
Yeah. So it is advisable. It is highly recommended to create 2 aggregate at least. Okay, per node. If you don't have more space, more disk, then at least you can create a two aggregate. Okay, and you have to make it balance as well, right?
I see.
Okay. Okay. Suppose 2 aggregates is there. Aggregate 1 is for node 1. Aggregate 2 is for node 2. So you are going to create a volume, right? So you have there is 150 volume you have already created in aggregate 1. Yep. And there is 50 volumes are there in the aggregate 2. So this is not balanced basically.
Balance, yes.
Right. So you have to make it balance. 150 there, 50 there. This is unbalanced, right? So you have to make it balance. Okay. Right? This is advisable. Yeah. Okay. So we were discussing about that particular command, aggregate show -r. I want to see the granular more information about this particular aggregate. Okay. Okay, so you can see this complete information about the aggregate 1 here. It will show owner node. It will show you the owner node here, right? So node 1 is owner of this aggregate, right? Aggregate name. It is showing online state. It will show here online state. Red information is showing here. Red DP. Okay. Plex it is showing here. Plex information is there. Red group. This is showing here RG1 means this is a red one. Basically, this is first red in this red aggregate. This information is showing. This information is showing here. This is this. The naming convention a little bit different since this is demo machine. Okay. The pool information over here. This type it will show here. Usable capacity, the physical disk, and the status is showing over here. Right. So this command will show you the complete information about the aggregate.
So how many disks did you choose for this?
I choose, you can see here, 1, 2, 3, 4, 5, 6, 7. 7 disks I have chosen for aggregate 1 and red DP.
Aggregate 1. Okay, so what's the one below it? Okay, you created 2 red groups? No.
No, not two red group. Okay. This.
The one below? Oh, okay, what is that below one?
Below one, this is complete information is showing here. You can see that this number is 37, 38, 39. Okay. So this is the same red group. It's completely showing about information. Okay.
Okay, normal block checksum. So isn't 14 and it can okay, so 1, 2, 3, 4, 5, 7. So by one look, it feel like you have two raid group, but it's really not.
It looks like, but it's not
Yeah.
two red groups. Why it is showing? Because this is granular report. It is showing. This is a plex basically. The plex is basically when you are mirroring the aggregate in the, that is concept of metro cluster,
Oh, right.
right? So we are displaying we are displaying the granular level, right? Complete information we have displayed here with this command.
Okay. Okay.
Okay, so that's why it is showing the complete information about this particular aggregate.
Oh, okay.
Okay, otherwise you can see this is the aggregate, this information.
Okay, I see.
Okay. Okay, so now, okay, so this is storage aggregate show status aggregate this one. So this is a similar command basically. This is not more granular, but this will show you the aggregate information, particular aggregate information. Okay. Okay, so this command will show you how to create the aggregate basically. Storage aggregate, you can see here. This command will also work, but this is a complete command for storage aggregate, create hyphen aggregate, and you have to mention the aggregate name as per your the company naming convention, what it decided, right? Then you have to mention the node, on which node you want to create the aggregate, right? So node, you have to mention node 1. Okay, so this is very mandatory information. Discount you have to mention over here if you want to take the number of the disk. Okay, if you want to take the number of the 5, 6, 7 disks. Okay, so you have to mention 5 disks. Minimum 5 disks is required for the RAID DP, right? If we are creating a RAID 4, then we need a 3 disks for the data aggregate. And if we are if you want RAID take, it means we require RAID 7 disks is required, right?
Okay.
But what happen if you want to take the particular disk, right? You have displayed the disk show command. For 24 disks are there. Like dot one, I'll show you what I'm saying. Suppose you have you have run this command, right? But
Okay.
you want to take this, you want to take the aggregate, you want to create the aggregate, but you want to take this specific particular drive, right? You do not want to take 5 disks, 7 disks like this. You
Yeah.
want to specify, if you want to specify the disk number, like you want to take 28, 29, and then 33, 34. In that situation, you have to change the command here. You have to mention the disk list. Disk list. Okay, I'll tell you here.
So you can pick what disk you want on.
Yes, you have to pick the disk number. Okay, and then you have to add the number of the 5. You have to mention that disk number and comma and all that. Okay, and then you have to specify the RAID group, and then it will hit enter. It will create the command. Okay, so this is the one RAID group in the aggregate, right? We are creating one aggregate 1.
Yep.
In node 1, right? So this is aggregate 1, and RAID is also 1, right? One RAID group, we have created one. Suppose you want to in the aggregate, if you want to specify how many maximum disks you want to add in this RAID group, right? Suppose if you want 5, right?
Yeah.
If you mention over here count disk count is 5, but you think that later on you need more aggregate. If you aggregate full threshold, it will cross the threshold. You need to add more disks in the same RAID group only, right? In the same RAID group, then you have to specify over here is max disk count. Okay, so you here only you have to specify how many. Suppose 14 you have mentioned here. So later, once you hit enter, the aggregate will create for now, right? But later, after 1 month, 2 months, you will realize that you need more space in this particular aggregate, and this particular RAID group only. Okay, so once you run the command storage aggregate add disk, and this aggregate and discount 2, it will add to this one because it is already allowing till 14 disks.
Yeah.
Okay, but in case you have mentioned here 5, okay, so it will not allow you to add more disks in the same RAID group.
So it's always better add more there. So let's say 5 months from now, let's say I put max discount is 24, and
Yes.
6 months from now the disk is getting full. Then
Hmm.
I go add more. I get another disk array, add it to the what a cluster, and then I go and I add using the same command, but as a storage aggregate add, and then tell what aggregate, and I add more disk, or even I can list the disk and then put it back into the cluster O1 aggregate AGGR1. Is that right?
Yes.
Okay.
So if you want to add more disk in future, so normally it will take by default in this same RAID group. Okay.
Oh.
If you want the same RAID type, if you are adding, if you want RAID TP, then because it is allowing 24 till 24, okay, so it will add in this one only. But if you want another RAID group, you can create another RAID group in same way. You have to run this command, storage aggregate add disk, and the same aggregate name, right? Disk count, whatever count is, suppose 12, and then you have to run this same command, right? Disk type,
Okay.
RAID type.
But you want to keep all your data together, right? So you would always
Yes,
go back to the.
the data will be all together only.
Oh, okay, got it.
Data will be, the aggregate is only same, right?
Uh-huh.
Aggregate is same, the data will be the
Yes.
all together only. This will not be separate. Only
Okay.
RAID group is getting separated, right?
Okay.
Data will be same only. That
Okay.
aggregate is same, the data will be same, not
Okay.
aggregate all.
Okay.
Okay. Okay, so this is all about one more thing. This I would like to tell you.
Uh-huh.
In future, suppose there's if you want to suppose you have created 24 days or 16 days aggregate, and this is a big size.
Uh-huh.
This aggregate is not being utilized, right? You want to you later you are realizing that this aggregate is all time empty, right? You want to shrink it. So in
Mhm.
that situation you cannot shrink, but you can grow it. Here
Mhm.
we are discussing about the growing, right? We cannot shrink it.
So that's why you start with 5 and then max count 4. Now where you can expand.
Yes, exactly.
Okay, makes sense.
So this is for the grow, but we cannot shrink it. So suppose if you want to shrink it, what
Mhm.
you have to do is you have to create suppose, let me show you this command here.
Mhm.
Right, this is aggregate one, right?
Mhm.
This is agar 1 and 1, this is aggregate.
Mhm.
Later I realized that there were no volumes and space are too much in this one. I just want to shrink it and make it to aggregate within this space only. But this will not happen. What in that situation, what we'll have to do is we have to create a similar aggregate, right?
Mhm.
And we have to move all the volumes in that new one, right?
I
New aggregate,
I see.
and then we can destroy this one. In that way we can save the space, right?
Okay. So,
Suppose this is the 110 GB, right? We want to 50 GB
yeah.
aggregate. So in that situation we have to create a 50 GB aggregate, and then we move all the volumes to that one. That is non-destructible. Basically we can move the volume
Oh, okay.
to different.
Volume can
Okay.
move around in different aggregate, but aggregate
Yes.
cannot
Shrink.
minimize, cannot shrink. So yeah,
Yes. Yeah.
good point. Good point.
Okay. So this is all about this command. Should I share here in this chat?
Yeah, you can share it. You can share it, or I'm recording, so no problem. I can type it, or you can put it in the WhatsApp group.
I'll ask Mani to share that with you, even diagram and this command details.
You're in the WhatsApp. It's a new WhatsApp group now.
Yeah, that is
Yeah,
WhatsApp group. I'll share there in that
that
one.
would be better.
Yes,
So
that is good. Yeah, that is a good one.
So I think this one is nice, very nice. I'm clear now, but now I'm going to go back in the lab and try to understand the difference between disk and RAID group, and try to kind of add some disk and see how it goes. So yeah, I'll do some practice, but I'll come back with some questions tomorrow if I have.
Sure, no problem. It will do.
Okay.
Okay, so we end up the session today.
Yep.
Okay.
Thank you so much.
Okay, and we'll meet you tomorrow. Okay,
Okay.
Shaji. Thank you very much. Okay. Bye bye.